So in this video, we're going to talk about something called the Triangle Midsegment Theorem. And a midsegment is exactly what it sounds like. It takes the midpoint from one side and the midpoint from another side, and it just connects them. So segment BD here is what we would call a midsegment. It connects two midpoints. So take a minute and predict, what do you think we might know about segment BD versus AE? One thing you might know based on previous stuff is that they are parallel to each other. And then also think about their lengths. What do you think the length of BD is compared to AE? Like if AE was like 20, what do you think BD would be? Just kind of looking at that. So to explore this, I did put a link on Google Classroom if you want to play around with it. It's on GeoGebra. And so here's a bunch of midsegments all connected. MN is the midsegment of BC. MO is the midsegment that goes with this side. And then this is the midsegment if we connect these two midpoints. Notice I have all their links here. So like if we compare MB is this, to AM, where's AM? Oh, right here. Those are the same because this was a midsegment, so it cut it in half. Also, if we compare AB, which is this, to, where is its midsegment? NO, these are all out of order, so sorry. If we compare AB to NO, what do you notice? Or if we compare BC to MN, what do you notice? Or if we compare AC to MO, what do you notice about those links? And even as we move it around, what do you notice about? First of all, see how they're staying parallel? So like, let's just look at these two. Do you see how they remain parallel no matter how I move that triangle? Same thing with these two sides, they stay parallel, or same thing here. Also notice the lengths, 10.22 compared to 5.11. This is 10.22, this is 5.11. And that stays consistent even as I move these. See how this one is exactly double this one? Okay, so that is pretty much the theorem. First of all, if you have a segment joining the midpoints, which is a midsegment, first, it will be parallel. We know that for sure. And not only will it be parallel, it will be half the length of this third side. So whatever AE is, this is half of AE. Or whatever BD is, AE will be twice that. So this is twice BD. So remember, this is kind of has to do with the triangle proportionality theorem, which says if this line right here is parallel to this one, then it cuts your triangle into proportional pieces. This goes a little bit further and says, not only is it parallel, but it actually is right in the middle of those two sides. The same theorem from before will hold. Like let's say this is 2 and this is 2. That's still, and let's say this is 3 and this is 3. That ratio will still hold. If this is 2 over 2, that's the same ratio as 3 over 3. So the fact that those proportions are the same will stay, just because these are parallel. But again, it goes even further to say this is exactly half. Like if this were 20, this would be 10. That doesn't always happen with any parallel line. Like, well, let's just put one on here. If I have a parallel line right here, let's say this is also parallel to those. Whatever these pieces are, they would still be proportional, but this would not be exactly half of that. Okay, so a few examples. I want to find the length of XW. I note that it's a midsegment because it's the midpoint of this, and X is the midpoint of ML, And so all I need to know is that it's half of 8, 4. All right, on this one we're just going to name some parts. So name a midsegment of the triangle ABC. DE would be a midsegment. Name a segment parallel to AC. Since DE is a midsegment, I know it's parallel to AC. So once again, DE. Name a segment with the same length as BD. BD is right here, and since this is a midsegment, it cuts it in half. So BD and DA are congruent. A segment half the length of AC, this is AC, DE is half of that. And a segment with twice the length of EC, EC is right here. These two are the same, so if I want a segment with twice the length of EC, that would be this full side, BC. Finally, just a few more problems. Go ahead and pause the video and again, try these problems on your own, and then you can watch me go over them. All right, the first thing I want is the measure of ST, which again, note ST is a midsegment. It's the middle of this side, it's the middle of this side. Connect them, it makes a midsegment. So if PR is 24, half of that would be 12. That's the answer here. PU is right here. Note that this entire thing is 24, cut into two congruent pieces, so this would also be half of 24, 12. That will always happen. If I were like connect all three of these, this would be 12, this would be 12, this would be 12, the whole thing's double that, 24. Measure of angle SUP, S-U-P, is right here. The way I can find that is, remember, if this is a midsegment, I know that it's parallel to this side right here. And since these are parallel, and this right here is a transversal, these are in alternate interior angles. So this is congruent, it's 55 degrees. And angle SUR is right here, S-U-R. Since I already know this one's 55, and all of this makes a straight line, all of this should be 180. These two are supplementary. So do 180 minus the 55, and that would be 125. All right, number 5 here. Again, it's a midsegment, and so I know that this is half of this. So there's a couple different ways you could solve for x here. One is, I know that if I take this and double it, it will equal this. Alternatively, I could take this and cut it in half and set it equal to x plus 1. Either way, you'll get the same answer. I'm going to go with the first option. So 2 times the x plus 1 should equal x plus 9. Because if I double this, I'll get here. Distribute the 2, and that's 2x plus 2. Then subtract x from both sides. So 1x plus 2 equals 9. Subtract 2, and x is 7.